The solicit message is very similar to the DHCP discover message we had with DHCPv4. However, it is a multicast instead of a broadcast. Why? Because with IPv6, there are no broadcasts. Broadcasts do not exist, so we need multicast to replace what was traditionally done with broadcasts. So the solicit message is going to be responsible for searching out and finding that DHCPv6 server. We are requesting the services of the DHCP server. If we examine a Wireshark capture, the DHCP solicit message, as we can see here, is originating from PC1, 06D6. The destination. Now, I can't say PC1 there. Let me start this over, because I'm not going to show you PC1. Got to be careful here. All right, so back to here. Let's try it again. The solicit message is very similar to the DHCP discover message for IPv4. However, it's not a broadcast anymore. It is a multicast message because broadcasts do not exist with IPv6. So this solicit message is responsible for searching out and finding the DHCP servers that could provide the client with the addressing information that it needs. If we examine a Wireshark capture, we can see this solicit message is clearly multicasted. Notice it's coming from a source of 06D6. So the client has the MAC address of 06D6, and it's sending it to this special multicast MAC address that is reserved for all DHCPv6 servers. So whenever you see 33:33:00:00:01:00:02, that is the MAC multicast address reserved for DHCPv6 servers. If we go up to the layer 3 header information, we will see here that the solicit message is sourced from the IPv6 link local address of the device, and it's destined to this really interesting looking IPv6 multicast address, FF02:1:2. This is the all DHCPv6 servers multicast address. Let me repeat that. The all DHCPv6 servers IPv6 multicast address. So here's two new multicast addresses that you've been introduced to. The MAC multicast address for DHCPv6 servers and the IPv6 multicast address for DHCPv6 servers. The next message is going to be the advertised message. The advertised message is unicast back from the server to the client. And this advertised message contains the information that the client's looking for. I'm looking for an IP address, looking for a mask, a prefix, default gateway, DNS server information, all of that stuff. So the advertised message is coming back. And the server, in the meantime, has put together this package for the client and has advertised it to the client. Now, we have to realize that DHCPv6 works differently than DHCPv4. The server is not going to hand out explicitly IP addresses to the client. It's handing out the prefix to the client. It's telling the client the prefix is 2001:DB8 /64, and the client goes, okay, I'm going to use EUI64 to configure my own interface ID. So we're advertising the information that is necessary for the client to set up everything that it needs to set up from an addressing standpoint. And it's unicast back, as we mentioned. And if we look at our capture, we can see that. The source MAC address is the server. The destination MAC address is the client. The source IP address is the link local address of the server. And the destination IPv6 address is the link local address of the client. The next message in this process is the request message. And the request message is the client indicating to the server that is going to use the information that was provided by the server. So if there happens to be any reservations that have to be made, then the server can finish finalizing those reservations for that particular client. And this request is a multicast going back as well. If we analyze the request that was captured here, we can see that it is sourced from the MAC address of the client and destined to that all DHCPv6 servers MAC multicast address, and the IPv6 addresses at layer 3 are going to be the link local address for the source of the client sending the request, and the destination is going to be, look at that, what is that? What is it? That's right, it's the all DHCPv6 servers IPv6 multicast address of FF02:1:2. And then finally, the very last message is the reply. The reply comes back from the server indicating that everything is good and the client can fully utilize all the information that has been provided to it. When we examine that reply, we'll see that it is unicast back. We have a specific source, specific destination, MAC addresses, and we have a specific source and destination IPv6 link local address that is being utilized. So this is a four-way negotiation process for DHCPv6. However, DHCPv6 also has a rapid negotiation process whereby only the solicit and reply are used. There is no advertise or request process in between. We lose a little bit of security here when we utilize this two-way version instead of the four-way version, because we missed the whole advertise and request to make sure that everything is accurate, everything is as we intend it to be. Instead, we are rapidly moving from solicit to reply. And this is effective in extreme mobile environments where users potentially are moving from one network whereby they have a certain IP address to another network and then to another, and their IPv6 address keeps changing depending on where they are. If that's the case, then we want to go through this negotiation process as rapidly as possible, and we can use a two-way version instead. And in order to accomplish that, both the client and the server must be able to support the rapid commit option for DHCPv6.